further. So as you can see, we are given with four options. The option A state both assertion and region are true, and the region is the correct explanation of the assertion. So if you have both assertion and region as true, and if region is the correct explanation of the assertion, then only we take we option A, or then only we take option one. Then secondly, if you observe that both assertion and region are true, but region may not be the correct explanation of the assertion. If this is the case, if region is not the correct explanation of assertion, then we go for option B. For option C, if assertion is true and region is false, and we go with option D if age false. So if age false, then you have the only option, that is D. Now observe the first question. If the net external force on the body is zero, then its acceleration is zero. So what can we say about the assertion? Is the assertion true or false? Yes. Why no one is answering? I just want to know whether the assertion is true or false. See, if the net external force on the body is zero, then its acceleration is zero. Okay. So is this statement true or false? Yukta?
Yes, sir.
Okay. What about the statement? Is the statement true or false?
So it's true.
Okay. Assertion is true. We can see here, we can write F equals to MA. If we write F equals to MA, if we write F equals to MA, so as here F represents, so if we have net force equals to 0, if I put F equals to 0, we get acceleration equals to 0 by M, then we also get acceleration as 0. So assertion is true. If the net external force on the body is 0, then its acceleration is 0. So this statement is true. The second statement is acceleration does not depend on force. So is this statement true or false?
False.
Yeah, the statement is false. This statement is false, as acceleration is dependent on the force. So which option we will go with?
Sir, C.
Yeah, we will go with option C. A is true, but R is false. That is the correct answer. Okay. So question 2 and 3 you can do. They are the direct questions. Let's see the short answer question. Question number 4. All the cars are provided with seat belts. Okay. So why the cars are provided with seat belts? You also had a subjective question from this. Sampath?
Yes, sir.
Yeah. So why the cars are provided with seat belts?
Sir, in case of any collision or accidents, the comes to rest abruptly, that is suddenly, but the passengers inside, due to inertia of motion, they continue to move at the same speed, and thus they fall front from the window. To avoid these accidents, the cars are provided with seat belts.
Okay, very good. Very good. And the next question, a hammer strikes a nail with a hammer strikes a nail with a hammer of mass 500 gram, moving with a velocity of 20 meter per second. The hammer comes to rest in 0.02 second after striking the nail. Calculate the force exerted by the nail on the hammer. So let's see. I'll try to solve it out. If you know, you can solve it out. You can start trying. I'm solving it out. But if you want, you can continue to solve it. Okay, so the hammer itself has a mass of 500 gram and we'll be converting this mass to SI units. So mass of the hammer will be taking as 0.5 kilogram. It's 500 grams, so we take it as 0.5 kilogram, moving with a velocity of 20 meter per second. So hammer has a initial velocity. It is initially moving with a velocity of 20 meter per second. See, question is given to you. You need to abstract the information from it. So hammer is initially moving with a velocity of 20 meter per second, and the hammer comes to rest. That means the hammer comes to rest. That means the final velocity of the hammer is 0. So here we have the final velocity v of the hammer to be equal to 0. The time that it has taken to become 0 is 0.02 seconds. So you can also say the time of impact, or you can also say the time taken by the hammer to stop is 0.02 seconds. Got
Sir,
it? So yes,
sir, is the force exerted minus 500 Newton?
okay. So let's check out. Anyone else who has done? Rohit, have you solved the questions?
So still solving.
Okay, solve it out. I want all of you to solve it. If you can solve it, just solve it. If you don't get it, Shravan,
Yes, sir, I'm doing it right now.
okay. Jitendra,
I'm doing, sir.
okay. So we use the formula F is equal to MA. So either you
Sir,
find
it's,
out your yes.
so the answer is negative 5,000.
Okay, let me check out. Your acceleration is 0 minus 20 divided by 0.02. So you get
Sir, which is negative.
negative 2000.
No, sir, 1,000.
Okay, yeah, negative 1000. Sorry, my bad. It's negative 1000 meter per second square. You have negative 1000 meter per second square as the
Sir,
acceleration.
sir, if you
And
multiply 0.5,
yeah,
we get negative 500 meters, I mean, Newton.
yes,
So
yes, you are
0.5 into
getting.
1,000 will be 5 kg meter per second.
So you have
Minus 5,000
0.5, yeah, multiplied with 1000, you get negative 500. Okay. You get negative 500 Newton as the force. So force exerted by the nail on the hammer is negative 500 Newton. Everyone got the same answer? Pranav? Jitendra?
Yes, sir.
Did you get the answer?
Yes, sir.
Okay, can you show your working? Jitendra, can you show your working?
Yes, sir.
So just show your working. Are you turning on the camera? Yeah, show it. You need to remove the background. If
Okay,
you
sir.
don't remove the background, then it won't come. You need to unblur the background. If you unblur, then only it will come. No issues, Jitendra. No issues for the background. Okay. You can just unblur and then show it. Yeah. Okay, Rohit, wait, Rohit. Just take it a little back. Jitendra, take it a little back. A little back only I'm able to see the question. A bit more. Yeah. Okay. Okay, Rohit. Just 1 minute. Rohit, let me show. Just I'm not checking everyone's. I'll check. Okay, you also calculated this way only. Okay, you are correct. Correct, right? See, there is still another way. Either you first find out the acceleration, or you can find out the rate of change of momentum. You can also find out the rate of change of momentum, and then you can find it out. So both ways you can go. Just wait for 1 minute. Yes. Wait. I'm just opening one of the book for more questions. No, should be 54. So we'll see some more questions here. Okay, let's try out these questions. For question number 1, question number 2. Let's see. We'll be doing here currently question number 2. Okay. So can everyone see the question number 2 clearly?
Yes, sir.
Okay. You see, a force acts for 0.1 second on a body of mass 1.2 kilogram initially at rest. The force then ceases to act and the body moves through 2 meter in the next 1 second. Find the magnitude of the force. So just first read the question, abstract what all information is given in the question. Abstract all the information that is given in the question.
Sir, the body moves to 2 meters in 1 second, no, sir?
Yeah. Okay. So what is the initial velocity given here?
Sir, 0.
0. The body is at rest, so initial velocity is 0. And
Initial velocity. Sir, final
what is the
velocity
final?
will be,
Hmm.
sir, it will be
Yes. What will be the final velocity?
2 meter. Sir, acceleration is 2 meter, right?
No, acceleration is not given here.
Oh, sir, 1 second.
Acceleration is not given here.
Sir, two.
Okay, we have here final velocity. See, when the force ceases to act, that means when there is no force. So if there is no force, then
Sir,
acceleration is zero,
zero.
and the object moves with a constant velocity. So with the constant velocity, it is able to move 2 meter in 1 second. That means if I find out the final velocity, so final velocity with which the object is traveling, it is 2 meter in 1 second, which is
Sir,
displacement by time,
is
2
the
meter,
displacement
2
upon
meter per
time.
second. Yeah. So the final velocity we have got here as 2 meter per second. The time for which the force act is 0.1 second. The mass of the object is also given. The mass is given as 1.2 kilogram. Okay. So again, now find out the acceleration. Once you know the acceleration, then you can find out the force. Yes, Sampath?
Sir, the answer would be 24 Newton.
The answer would be 24 Newton. Yes. Yeah, it's correct.
Yes, sir.
So anyone else who has found out?
Sir,
Yeah, anyone else who has calculated the answer?
sir, minus. Sir, 2.4
You have,
kg meter per second.
is it 2.4 or 24?
Sorry, sir, 24 Newton. Force, right? Yes, sir.
Yeah.
24 Newton.
Yeah. So acceleration, if you find out, so acceleration will be v minus u over t.
Sir,
So
it will be
acceleration we get,
2 meter per second.
no, it's
Sir,
20.
so it becomes 20
Acceleration,
by 10.
no, it is 20 over 1, which is 20 meter per second square. See, v minus u
No,
over
sir,
t,
but
this
there's
is 0.2.
0.1, right, sir.
Okay. So it's
Sir,
20
2
meter
by
per
0.
second square. Yeah.
Nothing, sir. Okay, yeah, I got it,
So
sir.
you
Never mind.
we have
Sir,
force
20
is
into
equal to,
1.2 is 20.
yeah. So mass times acceleration. Mass is 1.2 multiplied with the acceleration, which is 20. So we get here 24 Newton as the answer. 24.0 Newton. Now see the next one. Okay. See this. I'm leaving this to you for a practice just now. Solve it out, and I'm also solving it out. Try it, everyone. A ball of mass 10 gram is moving with a velocity of 50 meter per second. On applying a constant force on ball for 2 seconds, it acquires a velocity of 70 meter per second. You have to calculate the initial momentum of the ball. Calculate initial momentum, final momentum, rate of change of momentum. Okay, can anyone tell the initial momentum?
Plus 0.5.
Sir, initial momentum.
Yeah. Initial momentum is 0.5 units.
0.5 kg.
Meter per second.
Kg meter per second. Initial momentum is 0.5 kg meter per second.
Sir, and
Then
final
what is the
momentum will be 0.7 kg meter per second.
Yeah, this is 0.7 kg meter per second.
Sir, rate of change of momentum is equal to mass into velocity.
No, you can all rate of change of momentum, you can find out the change of momentum by time.
Yes, sir. Sir, we can do final momentum minus initial momentum by time, right?
Yeah, yeah. That is how you can find out. So what is the rate of change of momentum?
So
Sir, 0.7 minus 0.5 upon 2,
Yeah.
which is 0.2 by 2,
Hmm.
which is 0.2 by 2.
Okay, so you divide 0.2 by 2.
0.2 by 2. So
Yeah,
it will
what
be
is the
20
answer?
by 20. 20 by 20, which, no, sir. 0.1. Yes, sir.
This is 0.1. Okay.
Yes, sir.
And what should be the unit for it?
Sir, it will be momentum is kg meter. One second.
Okay, come
Sir,
on, tell the
isn't
unit for it.
meter per second, meter per second.
No. Jitendra, what should be the unit for the rate of change of momentum?
Kilograms meter per second.
No. It is C. You have the
Yes,
change
sir.
of momentum will be in kilogram meter per second. Okay. The rate of change of momentum would be
So Newton.
Newton. Very good. It would be Newton, or you can write it as kilogram meter per second square. So you write it Newton or kilogram meter per second square. See how we obtained this. We can recall the definition that force is the rate of change of momentum. So exactly, if you are asked the rate of change of momentum, it is the same as force. Or if you observe the units here, this change of momentum is in kilogram meter per second, and this divided by time, that is 2. So it makes it kilogram meter per second square. And kilogram meter per second square is nothing but force only. So your answer is 0.1 Newton. Now, the acceleration of the ball. Can you find out the acceleration?
Sir, 10 meter per second square.
10 meter per second square. Okay. The answer is correct. It's 10 meter per second square. So there are different ways you can find out the acceleration now. Acceleration can be found out either using the formula F equal to ma, or you can use V minus U by T. You can use both ways and you'll get the value of acceleration here. We will get here acceleration to be equal to either we get it F by M, or we can use V minus U by T. Both ways we'll get it as 10 meter per second square. Got it?
Yes, sir.
Then
And the magnitude of force applied will be same as the rate of change of momentum, no, sir.
yeah, the amount of force applied will be same as the rate of change of momentum, which will be 0.1 Newton. This is 0.1 Newton. Got it?
Yes, sir, got it.
Okay. Now see the next question.
Sir, I had a doubt.
Yes.
Sir, in motion, I have only a certain part of the chapter.
Hmm.
Sir, is it possible for you to send a worksheet for practice on the group so I can practice on motion?
Okay, sure. Okay, sure. I'll be
Yes, sir.
sending out
Thank
in the group. I think I have already sent one of the worksheet. Okay, but I'll be resharing it. Or maybe some other worksheet I will share.
Sir, I think it's only the velocity time graph, so could you just send one with important questions so I can practice?
Okay. Okay, I'll do that. Okay, start with this question now. A cricket ball of mass 100 gram moving with a speed of 30 meter per second is brought to rest by a player in 0.03 seconds. So find the change of momentum of the ball and the average force applied by the player. Okay, so let me see who all have done this. Yeah, Mohammad Rayan, can you tell me the change of momentum?
Yes, ma'am.
Next is Shravan and Pranav. Pranav? Pranav, are you there? Pranav? Okay, Pranav, is your mic and camera not working? So if your mic and camera are working, just turn it on. Yeah, Sharman, can you show what you have done for this question?
So I haven't done it, sir. So the question.
Okay, just let me see how much you have done.
I'm doing the second one. Try to do the second one.
You are given mass
I'm doing
and
the second one. I didn't do the
second.
first one.
Okay. Okay, so do it and keep your camera on. Just
Okay,
keep
sir.
your camera on. Your camera should not be off. I want everyone to do. I'm resharing the screen here. Okay, Pranav, if you are outside, no issues. But I have told you to inform in the support group. Okay, before the class, inform in the support group. Okay. Still, no one has done this. Has no one done this? The change of momentum.
Sir, I did, sir.
Sir,
Yeah,
one
Jitendra has.
second.
Okay.
Sir, I'm getting 3 kilogram meter per second.
Okay, so Okay, it is 3 kilogram meter per second. Is it positive or negative?
Sure, negative.
Negative. You are getting negative 3 kilogram meter per second. Okay, so change in momentum for this question. We have the change in momentum denoted by the symbol delta P will be equal to m v minus mu. Okay. So mv is 0.1 multiply 30. 0.1 multiply 0, since final velocity is 0, minus 0.1 multiply 30. So you have your answer as negative 3 kilogram meter per second square. Change of momentum is negative 3 kilogram meter per second square. Then the second one, you have to find out the average force.
Where will the average force be negative 100 Newton?
Average force, okay, I can see Jitendra Rohit Sampat Sarwan. Okay. Average force F will be equal to change of momentum delta P divided by time. So it would be negative 3 divided by 0.03.
So negative 100.
Yeah. So it would be negative 100 Newton. The force is going to be negative 100 Newton. Shravan, have you done this?
Sir, I did. But I think I got the wrong answer.
Okay, so can you show how you have done? Just 1 minute. 1 minute, 1 minute. Yeah. Show it now. Hold it steady. See, you are doing everything. Just your calculation mistakes are there. Okay, Yukta, can you show your answer?
So can you
Okay, this is delta P negative 3. Okay, and just show the bottom portion now. Take your notebook a little bit upward. Yeah, negative 3. Okay, that's correct. Fine. Okay, anyone else who is facing any problem? Jitendra, are you there?
Yes, sir.
Yeah, you can lower your camera. You are not visible. Just lower your camera a little bit so that you should be visible there. Okay. I'll see some more questions. Okay. Now see question number 5 and question 6. So first we do question 5. We have two bodies A and B of same mass are moving with velocities v and 2v respectively. Compare their inertia. So what about their inertia? What can we say about their inertia? Okay, what is the factor on which the inertia depends?
Where the mass and the force. I mean,
Yeah,
velocity.
inertia depend on the mass. So can I say that the inertia of both of them would be the same?
Yes, sir.
Okay. And what about the momentum?
Sir, the B has greater change in greater momentum.
Yeah, B has a greater momentum and it is in the ratio 1:2. Okay. Some more questions here. Let's see. I have question number 4, 5, 6. So try solving question 4, 5, 6. I hope it's visible to all of you. A force of 10 Newton act on a body of mass 5 kilogram. You have to find the acceleration produced. Okay, so anyone got the answer for the first one? A force of 10 Newton act on a body of mass 5 kilogram. You just have to find the acceleration.
Sir, 2 meters per
Okay.
second square.
Okay, it's the direct answer.
Yes, sir.
Yes.
Acceleration is force upon mass, which is 2 meter per second.
Yeah. So this is 10 by 5, which is 2 Newton, 2 meter per second. Answer is also given here.
Next one
And
is
now
also
do the,
direct. Force is
yeah.
which is 2.5 Newton.
Okay, question number 5 is also a direct question. You have to find the force, which will be mass times acceleration. So this will be 0.5 times acceleration, which is 5. So you get 2.5 Newton. Multiplied, you get 2.5 Newton for the second one. For this one, you have this. For this one, you have this. And for the sixth one, start solving for the sixth one. A force of 10 Newton act on a body of mass 2 kilogram for 3 seconds initially at rest. You have to calculate the velocity acquired by the body and the change in momentum of the body.
Sir, the velocity acquired will be 15 meters per second.
Okay, velocity acquired, you are getting 15 meter per second. So for that, you first need to find out the acceleration here. Acceleration will be given by force by mass. So
Sir,
force
by this
is
or
10 over 2. Yes.
sir, sir, can we also do it with the method of delta P by delta T?
Delta P by delta T, you will get the change of momentum.
No, no, sir. We'll get no, sir. By initial velocity and final velocity, they gave no, sir. We
Yeah,
can
yeah. So, yeah, that's the same thing. You can get here F is equal to delta P by delta T. So, you'll be getting it by this method. You'll get force multiply time. So, 10 multiply 3 is going to be change of momentum, right? So, 30 kilogram meter per second will be the change of momentum. And now you can put the value of change of momentum as mv minus mu. So you can put here m times of v minus u. Since initial velocity is 0, so you put u as 0 and obtain the value of v, which you will get as 15 meter per second.
Yes, sir.
Got it? So either you use this method or you use directly, you use force equals to mass times acceleration, obtain the value of acceleration, and then use acceleration equals to v equals to u plus at, this formula. Use the first equation of motion. U is 0 plus acceleration is 5 and multiply the time, which is 3. So you get final velocity as 15 meter per second. Then change of momentum. Just we did the change of momentum and you will get the change of momentum as 30 kilogram meter per second. Anyone who is not able to do these questions? Yeah, questions of this chapter. We have this. Just see this question. The linear momentum of a ball. The linear momentum of a ball of mass 50 gram is 0.5 kilogram meter per second. Find its velocity. See, the linear momentum is given, mass is given, you have to find out the velocity. Find the velocity. Anyone got the answer? Anyone got the answer?
No, sir.
Try doing this.
Sir, I got answer 10 meters per second.
Okay. See, the answer is already here, but I think most of you are facing the problem. Use the formula of linear momentum. The formula of linear momentum P is equal to mv. Now, put all the values which are given in your SI units. So, linear momentum P is given as 0.5. So, you put here 0.5 to be equal to mass times velocity. Mass here is 0.05 multiplied with velocity v. It's 50 grams. So you just put 50 gram into kilogram. That's 0.05. Now you can obtain the velocity from this expression. V will be 0.5 divided by 0.05. So this you get as 10 meter per second.
Sir, I will do the same method.
So anyone facing problem or difficulty in this question? So see some question further. Okay, now see this a question from the graph. Figure 2.11 shows the velocity time graph of a particle of mass 100 gram moving in a straight line. Calculate the force acting on the particle. So the question is also very direct question. What all information is given, we find out here. So first of all, you are given the mass. Here we note down the mass of object to be 100 gram, and in SI units, this is going to be 0.1 kilogram. 0.1 kilogram. Now to find out force, we need acceleration, and we are also given here the graph of the object. So from the graph of the object, can you find out acceleration? Yeah, Jitendra, can you find out the acceleration from this? Jitendra?
Yes, sir.
Sarwan, can you find out acceleration from the graph? Sarwan, how will you find out the acceleration from the graph?
So we have to use a formula, right? V minus
Which
U by
formula to be used here?
V minus U by T something.
Okay, what is V?
V is the velocity,
Okay, and what is U?
initial velocity.
And what is V?
So what?
What is V?
V. V.
V.
V is velocity.
And U is initial velocity.
Yeah.
See, V stands for the final velocity. Okay. And U stands for initial velocity. Okay. So from the graph, can you find out the final velocity? From the graph, can you tell the final velocity?
20.
20. Okay. Final velocity V is 20 meter per second. So as we can observe at the at this time 5, it has the velocity 20 meter per second. And what is the initial velocity here?
10.
10. Okay, so initial velocity is 10 or 0?
10, I guess. 10.
10.
Yeah.
See, from the graph, you first spot the time which you want. Okay, so here we are taking the time, we are taking the starting time to be 0, and we are taking the last time to be 5. So we will be observing the motion during the duration of 0 to 5 seconds. Okay, so 0 second, it marks the beginning of the motion. 5 seconds marks the end of the motion. Okay, now at 5 seconds, the object has a velocity of 20 meter per second. So final velocity is 20 meter per second. But at the beginning of the time, when the time is 0, it shows the initial velocity to be 0. Okay, you can observe that 10 is somewhere here. If you drop a line from here, so you get 10 to be somewhere here. Okay, so to find out the acceleration from the graph, either you can use the formula of the gradient. We find out the gradient of the curve or slope of the curve. So either you find out the slope or you use V minus U. Since we are taking as 20, So initial velocity will be taking 0, which is the beginning of the time. So for the beginning of the time, we are taking u as 0, and the time which has elapsed to bring about the change from 0 to 20 meter per second is 5 seconds. So what is the time that has elapsed? It's 5 seconds.
5 seconds.
Okay. So time we take as 5 seconds. Now we'll find out the acceleration A, which is v minus u over t. So it is 20 minus 0 over 5. That is 4 meter per second square. So acceleration is 4 meter per second square. We have mass as 0.1 kilogram. See, it's 100 grams. So you will be taking as 0.1 kilogram. And now you can find out the force. Okay. So force will be equal to mass into acceleration.
Yes, sir.
So mass is 0.1 multiply with acceleration 4. You get 0.4 Newton. Yeah. Anyone having any doubts here?
No doubt, sir.
No. Okay.
No doubt, sir.
Okay. Let's see one more question and then we will end up the class. And here I just want you people, and let's see who can answer it quickly. So for question number 14. So there are three things which have been asked. Go through the question and answer it. Okay, so you can try it out. Just take a screenshot of the question, try it out, and we'll see again in next class. Okay. Okay. So by all of you, Shravan, I want to see your solution. Whatever solution you do, you can keep it ready. I'll be checking your solution for the next class.
Okay, sir.
All the questions which have been discussed over here. Okay.
Okay, sir.
Okay. Bye.
Yes, sir.